Good morning, everybody, and welcome to the latest Eurostat webinar on how to create maps using Eurostat data. I'm John Berender, and I'm working in Eurostat on national accounts data, but I think today's webinar is going to be really interesting and visual, which is exactly what we want. And I understand it's extremely popular already, so welcome everybody. The event will be recorded, so it will be available afterwards as well to view. Actually, this will be a rather interactive webinar in the sense that participants are able to send questions via Slido tool. I think you're well aware of the Slido tool from the announcement of the webinar. But here's the code that you need to use if you want to get to Slido in order to write your questions. So this is #3379387. The link's also available on the Eurostat stream page, so you'll be able to follow that there. So let's get into the webinar, and I'd like to introduce two speakers, two expert speakers who will be joining me today to take us through it. First of all, you'll see in the center Hannes Reuter. Hannes is a statistical officer at Eurostat in the GISCO coordination and projects. Welcome this morning, Hannes.
Good morning, John. Thank you for being here.
Great. And our other expert speaker here is Joseph or Joe Davis. Joe is a geographic information system programmer here in Eurostat. Welcome, Joe.
Morning, John. Thanks for having me.
Absolutely. So there's a lot of interest. So let's get into it. So first of all, we'll kick off with Hannes, and Hannes will give his presentation. So Hannes, please go ahead.
Thanks, John. Good morning, everybody. And I would like to take you on a little story before we go into Joe's presentation and ask, as we have introduced to you in the announcement, what is GISCO and what can it do for you? And you might wonder why, come on guys, GISCO, I have no idea. And the Commission is known for creating its acronyms, and that's the reason I want to take you on a little story so you understand where GISCO comes from and what we can do for you. So as we were reflecting a little bit beforehand, we were thinking, yeah, we need to introduce GIS to you. And I want to take you on a little trip for that one. I just want to put a hypothesis here on with you that every information has a geospatial component. And I'm highly challenged, I want to be challenged actually with Slido, so we can have a discussion on that in the Q&A session. So if we have saying that every information has a geospatial component, we need to define it somewhere in space and time. We need to bring it somewhere and locate it, and it goes down to mathematics. If we're talking space, and we need to talk about location. What is a location? I'm coming from a little town which is called Edessa, 1 hour south from Berlin, and you might have all used your cell phone in one stage, and I've talked about geographic coordinates with the GPS, which you see here, 51 degrees north and 12 degrees east from Greenwich. So we can define it, and with a number of decimals or coordinates behind, we can maybe define the street or as a house number or just the city, saying something like that. So we can define X and Y and say, where are we somewhere on Earth? But not only that one comes into space, but we also need to define where are we with a height. If we're talking about the digital elevation models, we want to describe the shape of the Earth, what's a height, or even if we're talking about a building, are we in the 3rd floor or the 5th floor, then we might need to introduce also the Z coordinate in that one. But I just want to bring you up, make it even more complex. Then we're talking about projections, and this is a topic which we cannot discuss in detail here today, but I just want to show you for the same coordinate which we have described here with degrees, we can also describe it with a metric system. And then here, this same rectangle I've shown here is a couple of kilometers north, 3,000 meters north, and again, 5,000 meters east from a place where we have defined the projection system, which we used for the European Commission use ETS, LEA. Having introduced you to this one, that this is how we can look, describe our definition in space, I just want to run you past you that this is needed for everything. It needs to be for our address, Rue Alphonse Weicker, where we're sitting here in Luxembourg, for the road, for statistical units, which we will see in a couple of minutes in the image tool, which we're using for visualization, even for countries, even for continents, and even on Earth. Why mention Earth? Because if we need to define, we could even define ourselves in the universe, because you might have heard about the recent announcement from the NASA, where they said, yes, we will now define time on the moon, right? So we have also on the world, we have different time zones. We need to specify or give our information a component in time with a date or an hour, minute, and seconds to describe it. So all of that one, if we want to work on that one, we need to have a system to capture, store, process, visualize geospatial data. My son just drew up a map here, and I hope you can see it, of the Netherlands. Well, in the past, we have done it like that. Now we have computers, right? So now we have a system for that one, and that's called Geographic Information System, a GIS. And this is now where I want to bring you up to speed where GISCO comes from, because GISCO stands for the Geographic Information System of the Commission. So we are a permanent service hosted in Eurostat since 20, 30 years. Please don't ask me why we ended up here. Someone back in the history decided that one, because they thought statistics and geoinformation is together, and we can also tell that this is really the case. And we're trying to answer the needs of the European Commission, Eurostat, and the European Statistical System for different geographical information at different levels. And you will see today how we do that. And for that one, we do it, first of all, for the Commission, but also we have some services or some information which we can share with you. And I just want to bring you a little bit of what we're doing here in Eurostat. So for that, first of all, we provide GIS reference data for the whole of the Commission. Also, you as a public citizens, you can get some of our data. If you go to Google Eurostat GISCO reference data, you can find it here, and you can find, for example, the NUTS or the urban audits, the Geostat grids, transport networks, our country data sets. We provide services based on these data sets to the whole Commission. We provide on a daily basis between 5 to 10 million users these services out to our colleagues, but this is mostly internal. We don't share it with the citizens or with the public at large. And we also provide software. So Image is one of these tools which is based, for example, on Eurostat Map.js. And in our GitHub repository here from Eurostat, you can find some of the tools which are not only developed by GISCO, but also other colleagues from Eurostat where the software is distributed. From GISCO side, we're also doing number of other activities, like we're supporting cartographic activities in the Commission for our colleagues in our regional statistics and geographical information unit. We have a Eurostat regional yearbook, and we're making all the maps in that usually. We're also doing analytical tasks where we're doing distance matrices or postal code analysis for the member states, and also accessibility matrices, accessibility analysis, for example, here for the European Court of Auditors, which is one of our European institutions. Besides that one, we also coordinate Commission-wide activities. We give guidance how to draw maps and how to set standards there. And we're trying to stimulate the use of GIS inside the Commission, as well outside in the statistical system. And for that one, we're supporting a kind of activities, starting it from United Nations level, the UNGGIM, The links to that one will be posted in Slido, and we're also supporting activities like the European Forum for Geographic Statistics, or on certain activities with the member states where we providing them, giving them guidance or help on the integration of statistics and geo information from that one. And you can find these reports on our websites for that one. In that due respect, what JISCO tries to do is doing what a GIS does. We're trying always to localize some information for ourselves, for our colleagues in the Commission. We're trying to provide these services. You will see it in Joe's presentation in a couple of minutes on, for example, the NUTS here, where we're trying to localize the information which is aggregated, comes via the statistical system to Eurostat, and we can visualize it. And we also do that for addresses, for administrative units, a whole range of points. If we have that one, if we have localized the point, as said, remember my earlier introduction, if we have X and Y, we have latitude and longitude and height, then we can try to analyze it further. And you see it here with a road network together with a population grid. And we can calculate out of that one, for example, the access to healthcare. So what's the travel time to the nearest hospital by a 1 kilometer grid? And for example, this map you will find in our regional yearbook publications, or also the statistical atlas. And last but not least, we have the block of visualizations, where we see here visualization thanks done by Joe, where we visualize the population grid from 2011, sorry, and show it how it distributes across Europe. And we have a number of activities like the image tool or Eurostat Map.js, where we're trying to support our colleagues with that one. And with that one, I'm thinking I'm at the end of my introduction to you here, and I hope it was informative for you. And thank you. And over back to John.
Thank you very much, Hannes, for that interesting presentation. Please stay with me because I've got a couple of questions for you. Yeah, don't want to stress you. You mentioned NUTS, N-U-T-S. What are NUTS, just for my benefit?
Okay, so thanks, John, for that question. A NUTS is a hierarchical classification. You want to divide, let's put it that way, the territory of the European Union to different statistical units, which are of equal area, equal size, even equal divisioning. So hopefully hierarchical, stable over time, aligned, and with a similar population. So you see, for example, here on the lower right on my slide, you see on the lower right on my slide that, for example, we have different population thresholds for the different NUTS levels, where we see, for example, for the NUTS 1, we want to have the population between 3 to 7 million, NUTS 2 and NUTS 3. And with that one, we can compare regions in Europe for regional statistics, for socioeconomic analysis, as well for the implementation of EU regional policies. And you see here on the top right, a little example how this is hierarchical classified. So for example, here we have an example from Germany, where you see in NUTS 1, I mean, we have all over Germany. Then the NUTS 2 goes into the federal level, and then we go down to the NUTS 3 level. NUTS 0 is the country level, NUTS 1 is already the federal Bundesländer, and then NUTS 2 and NUTS 3 goes down, really down to a single more manageable unit. Why we call it NUTS or statistical unit? Because for the NUTS there is a regulation in place for which we are reporting, and our colleagues in our unit from the regional statistics team are even responsible for that one. And we're also having the statistical regions with other countries which are in the European statistical system, which also deliver statistics for that one. But there, the European Union law doesn't apply, but we have agreements with them between Eurostat and the members, the state in question which delivers in the European statistical system.
Well, thank you very much. That's very, very good. Just on you personally, you're a geoecologist. How does a geoecologist end up doing maps here?
Thanks, John. How is ending a geoecologist? Well, I studied geoecology with a specialization in geographic information system, remote sensing, and soil science. And I was a scientist, you know, and we are educated to solve issues, environmental issues. And so we can talk with a lawyer, we can talk with a chemist, we can talk with a GIS person or social scientist. And this is how I ended up here. I have no idea because I passed the concours. This is an EPSO selection committee, right? Well, I mean, so I was a scientist, traveled around a little bit in different research institutions in the world. And now I'm here in Eurostat and I really love my work here in JISCO.
Well, thank you very much, Hannes, for the presentation and for revealing a bit more about your background. So thanks a lot, Hannes. Let's move on to Joe. Joe, you're going to get a bit more into the tool and demonstrate what happens in the tool. Please go ahead, Joe. I think you're muted, Joe.
Yeah, classic mistake. So yeah, just a bit of background on me. I'm Joseph Davis. I am the developer behind Image, which is our map making tool. Stands for Interactive Map Generator. So I'll quickly run through how to make a map using our tool. Bit of background on the tool as well. So it was designed with non-experts in mind. So the idea is you don't have to be a cartographer to make a map with your data. Maps are obviously very popular. They are constantly the most liked, shared, favorited posts on all Eurostat social media channels. So there's quite a high demand for making maps, and you know, teach a man to fish and all that. We like to let people make their own maps. So without further ado, I'll get into it. So you can see the tool here. The first page that you're confronted with is to add data. Of course, we need to add our data. So we have two ways of adding data. We can either link directly to the Eurostat database, or we can upload a file ourselves. So here's a quick preview of what that might look like. You would have an Excel file or a CSV file with pairs of nuts codes and values. Numerical values, or a colon if you want to show it as grey data not available. But to get started, we'll just select a Eurostat dataset. So we can either search for one ourselves directly, or we can choose one which has a high percentage of coverage. So you know, we want full coverage on our map, or we can select from a couple of predefined ones. So I'll go ahead and select GDP. So straight off the bat, it downloads the data, adds it to our map, sets a default color scheme and classification. So it's selected some filters for us. We can see here euro per inhabitant, the date, and the nuts level. As Hannes just explained, we have different levels of detail across statistical units. So it's gone with the highest level detail, and that's 3. So now that we have data added to our map, we can choose from a couple of templates. So these are essentially geographic extents. We have 3 types to choose from. We can choose from European extent. We could have a specific country extent, or we can have a global extent, a world map. So for the European templates, we also have a print version if you need a map for a printed publication, for example. So I'll go ahead and show you a country template. Here we have Austria. I could change that to Spain, for example. So it'll also show the overseas regions of that country. And I can also show the surrounding areas, so that the neighbors, Portugal, France as well, if I want to. Okay, so for now, I'll stick with the European extent. And the next step would be to choose the correct type of statistical map, right? According to our data, we might have to use a specific type of map or not. This is currently a choropleth. Don't worry, that's just a fancy word for mapping regions using color or shade or texture according to a value. So here we have euro per inhabitant assigned by color. So the light colors low values and the dark colors are high values on a light background. So we could use a texture as well, which is useful for people with color vision deficiency. And the other types of maps we have are proportional symbols. So this is for data that is a total, so essentially a total count of volume. So we're currently using GDP. If I change it, so here we got a little warning. It's telling us we're currently using the wrong map type, right? So if I want to use a proportional symbol map, I'll change the nuts level so it's not so cluttered. We should be using a total value. So this is million euro, so total amount. And then the choropleth map, so the colors would be assigned to a normalized data set. So per inhabitant, per square kilometer, which are called sort of intensive spatial values. So for now, I'll go back to euro per inhabitant. I'll go back to our choropleth, which is probably the most common type of map you'll see. And we also have categorical as well, in case you have a region assigned to a category, for example, urban or rural. You might want to assign a color. Okay, so next on our list is our color scheme. We can choose from a wide range of different color schemes. There are two different types of color scheme that we might have to choose from. So sequential or diverging. Now, don't worry, sounds complicated, but sequential is just values that progress from low to high, right? So here we have euro per inhabitant. We have a low amount of euro versus a high amount of euro. Now, diverging is where we have a critical midpoint, right? So say we have a data set where we want to distinguish between positive and negative. So population increase versus population decrease, for example. Well, in that case, we would use a diverging color scheme and we would set this midpoint to wherever the zero is, right? So one side of the scale would be positive values and one side would be negative. Now, if you don't have this kind of critical midpoint in your data set, do not use this color scheme. It's quite a common mistake where people like to use this color scheme because there's more contrast, but that's a pitfall in cartography. You shouldn't be using a divergence scheme unless you have this meaningful midpoint to distinguish between the two sides of the scale. And you also have a wide range of schemes here available, if you need to use them. So for now, as I said, this data set doesn't really have a meaningful midpoint, so we'll go back to the sequential. And the next step would be to define our classification, the class breaks that we have. So by default, it's loaded 6, so we can see them here. And say, for example, we want to increase that to 8, we can do so here. Now the classification method, so the method that's used to calculate these classes, we have quite a few. So we've got Jenks natural breaks, which does a good job in assigning a class to the outliers. So the values in our data set that are far away from the rest of the distribution, right? So that does a good job in making sure the outliers are sort of highlighted on the map. Quantile essentially makes sure that there are the same amount of values in each class, so it's a good spread. Equal interval makes sure that there's the same distance between each class, so for example 5, 10, 15, 20. And user defined, just lets us set our own. So I could change this here to whatever I want, and it would update the labels as well as I change the values. So I'll stick with Quantal for now. So whilst you're changing these classes, we also have a histogram view, which is useful for visualizing the distribution, and making sure you've got the appropriate class breaks for the data set. We also have a table view in case you want to sort of see the values in order, and yeah, just dive into the data. So go back to the map, and next up we can edit the text on our map. So here we have a title which is too long, so we can put some of that text into the subtitle. Titles ideally should be as short and sweet as possible, and we can also change our legend title, some footnotes. Yeah, we can add some explanatory text below the map, and we can add a source for our data set, which is already being loaded in because I've loaded it from the database directly. Okay, so we can also add some map labels. We can add country names, geographic names if needs be. And we also have some additional settings. These are just little things you can tinker with if you want to further customize your map. We also have a checklist, so we highly encourage people once they've made their map to go through this checklist to make sure they haven't made any grave mistakes. There are essentially three main points that you need to look at when you make a map, which is the map type, as I mentioned earlier, the map color scheme, and the map classification. So this goes through each potential mistake you could make and shows you a good example versus a bad example, making sure that you haven't committed any of the mistakes that I mentioned earlier. So we try and sort of hold the hand of the map maker through this process, making sure that they're not falling into any of these pitfalls. And then once you're happy with your map, you've gone through the checklist, your map is bulletproof, then you can download it as a number of different formats. You could have it as a PDF, you could have it as a PNG, SVG, you could even have it as a HTML and JavaScript. So what you're seeing here, this interactive version, you could export it as its own visualization, interactive visualization, which you could embed on a page if you want, or you could download them all. And this value at the top would be the configuration file. So that's essentially if you want to save all the settings that you've currently got loaded, and then say you want to share that map with someone, and they can load that file into Image and continue editing the same map. So it's sort of this option to save for later and load an existing map, which you would do so here by uploading the file. This is also more of a niche requirement, but if you wanted to generate a whole load of maps, say you got 100 maps for your publication, you could upload a load of those config files that I just mentioned, and it would generate them all in one go. And yeah, so that's pretty much it from the map generator tool. If you have any questions, I'll be happy to answer them. And yeah, I hope you enjoyed this little run through of the interactive map generator.
Thank you very much, Joe. That looks like a really nice tool, and we'll certainly get on to plenty of questions later in a second. So actually, I was sort of interested in a general question which many users may have, which is if I use this interactive mapping tool and then I publish a chart based on it, do I have to acknowledge that the software came from Eurostat, or I used a Eurostat tool? How does that work?
So in the tool itself, we always have we have disclaimers, we have the copyright text in each map. So that's already been added for you. So yeah, every map that you export, that will be taken care of.
Okay, that's clear. Thanks, Joe. And in terms of your background, you're a cartographer, so it seems more natural that you'll be handling maps. But how did you get into sort of the GIS GISCO part of the world?
Yeah, I guess a short and sweet explanation would be that I'm just a big map nerd. I've always liked maps, so that sort of took me down the path of geography. And from there, yeah, I ended up in the statistical realm. And yeah, the logical pathway for mapping statistics is to get into programming, and that's how I ended up developing this map generator.
Great. Well, thanks, Joe. It's anyway. So let's move into the Q&A session, and just to remind everybody that listening, that or watching, that the Slido is open for questions, and we already have an enormous number of questions there. So we're going to need to be quite efficient if we're going to get through most of them. Just to reassure people, though, if we don't get through all of them today here, then we'll be answering those in writing on Slido. So if your question's not answered, we'll certainly get to it. So let's kick off. So the first question is, how can you create, or how can I create maps data for one country divided by districts? And I think, Joe, you already covered that in your presentation, I understood. So let's assume that that's covered by your presentation. The second question, actually, how much data, or how much types of data do you have to create maps? I think that's for you, Joe.
Yeah, so I mean, image, you could upload qualitative or quantitative data. I mean, Eurostat has a wide range of data sets available. Yeah, I mean, if the question is the types of geographical data sets, I guess you could say that image is only for NUTS regions, as Hannes mentioned earlier. If you have different types of data, which GISCO also publishes, so you could say local administrative units or gridded statistics, then we have other tools for mapping those different types of data. For example, GridVis, which we've developed for visualizing gridded data. So yeah, if you have gridded data available, feel free to use those tools. As Hannes mentioned earlier, we have a GitHub page where all these libraries are open source, they're publicly available, so feel free to use them.
Thank you, Joe. We've got a third question, which is, I'm interested in detailed mapping at the lowest level of information gathering. How to distinguish details at the lowest level of regional organization, really the most detailed. How does that work?
I think I just may have answered that question then. So, as I said, gridded statistics could probably be considered the highest level of detail. If you have gridded data at 100-meter level, 1 kilometer level, you can map that using GridVis, which is the tool I mentioned earlier. If you have local administrative units, we also provide those. Hannes, feel free to
yeah, but I mean, maybe just to come in and step in. For image, we try to apply the KISS principle and really limited the focus for that one. If you want to map or make maps of your lowest knowledge base or your lowest coordinates, sorry, you use specialized dedicated software like QGIS, GVSig, the whole S3 suite from a commercial software where you have dedicated things. Here for the image tool, the attention is that we only provide in a standardized way for a really limited amount, and we only allow for the NUTS and the countries, and that's it. And you go for a dedicated, even in JISCO, you know, we are creating dedicated maps, but not using image. We're using different tools for that one, and I think this goes in this answers this kind of question. Image is not designed for that one and should not be designed for that one.
Thanks, Hannes. It is, of course, important that we have, there are different tools available. We can't put everything into one tool. I think that's the message, which is important. Then we've got a fourth question. Which technologies are used or will be used for creating map UI and API communication? That's for you, Joe, I think.
Yeah, great question. So the engine, if you will, of image, the map generator is a library that we've developed in-house. It's called Eurostat Map. It's a JavaScript library which generates statistical maps based on D3. So that is the motor, if you will. The UI, the user interface, we use EUI which is the European Commission's Angular components. So that's, yeah, just the JavaScript library we use, and the API communication. So I assume they refer to the data retrieval. So we link to the Eurostat database using the Eurostat statistics API. So, which is what enabled me earlier to see what data sets are available, to see their filters, and to download the data directly from the Eurostat database in whatever format I want. So in that example, I did it using a JSON format.
And maybe just to add to that one, you know, from JISCO's side, we're trying to provide APIs or build services on top of APIs, and this enables where people picking it up. And even for image, last year 8,000 maps have been done with image. You know, based on that one, we couldn't have done it ourselves as a service to the clients, but they do it themselves. So everyone else can come in, even with R or Python. There are packages out which have been developed by some Finnish colleagues, I think, using R packages, which are using the JISCO boundaries, downloading them from us, and then the statistical data from the Eurostat and API, bringing these data sets together and making the maps locally on their computer.
Okay, thanks to you both. So hopefully after this webinar, there'll be a lot more than 8,000 maps being created. Let's see. Then we have a question about languages. Does the tool go beyond English? How are other languages handled in the tool and in the information? Maybe Joe, please.
Yeah, so the tool is translated into all official EU languages. So at the top right corner, there's a little icon where you can select the language that you want. So this will translate the entire application and map text. And we try to update it once a year. So every year we'll send through the translations to keep it up to date.
Yeah, that's great. That's really important, of course, because this is really a European tool and we want the languages being represented so everybody can use it well. Then we have a question which I think, Joe, you answered in your presentation. You know, what types of file format are allowed with this tool? So if I understood correctly, it was you can upload data as Excel or CSV, and you can export the maps as PDF, PNG, SVG, or HTML JavaScript. So there's a lot of acronyms there, but was that right? Yeah, that seems to be right. So those of you who understand those acronyms will get the answer. Let's move on to actually quite a fascinating question for me, which is what unusual visualization methods can you recommend? I'm not sure what unusual means, but Joe, can you enlighten us, please?
Yeah, I mean, if we're on the topic of maps, so I'll go for unusual types of maps. Cartograms are a good route to go down. Cartograms sort of distort the geographical space in order to map variables. Probably my favorite would be the Dorling cartogram, which we use in some of our visualizations in the Regions in Europe publication, for example. So yeah, I think if you're interested in maps, then look up some cartograms. I think a famous one was Land Doesn't Vote, which was this animation of the US election map, which sort of distorted each county or state into a proportional sized bubble, if you will. So it's an abstract representation of the geography using a data set. So yeah, that would be my answer.
Yeah, that sounds really nice. I'll have to have a look on that, definitely. So we've got another question here. I think it's the 8th question. Where does your data come from? How often is it updated? Maybe Hannes, you can tell us a bit.
Yeah, okay. Thanks. Just coming back to that one, I mean, we have a variety of data which we are using. I mean, as we are European institutions, our main source are authoritative data provided by the national mapping and cadastral agencies via Geographics. However, we also procure commercial data, as well as using community-sourced information like OpenStreetMap, data from NASA, for example, for some of our background maps. So it's really a variety. For the update cycle, it really depends. I mean, on which kind of data set we are speaking about. Sometimes our country or NUTS data sets, we are updating only every 3 years due to the fact that the NUTS regulation is done every 3 years. But some other data sets are updated on an annual cycle. For example, the local administrative units, the LAUs. The population grid is will be updated this year, so we are on a 10-year cycle. So really depending on which data set you have is the absolute cycle and also where the data is coming from. So it's not such easy to answer.
Well, that's fine, Hannes. I mean, we understand data are updated at different times. And of course, one can always, if you're using Eurostat data, go on the Eurostat website to see the latest available data and when it was loaded. Let's swiftly move on because there are an enormous number of questions coming. So question number 9, are there any step-by-step guides to how to use the Eurostat data? And I think that would answer a number of later questions as well. Joe, is there a step-by-step guide around?
Yeah, so I mean, on the Eurostat website, there's quite a comprehensive wiki of how to use Eurostat data, how to download it, how to use the API that I mentioned earlier. But also within the image tool, we have a wide range of documentation of how to use Eurostat data, how to download it, how to visualize it. So yeah, wide range of documentation available.
Okay, there's plenty there to read. Maybe we'll post the link to the wiki as well in the Slido, and then everybody can find it. Then the 10th question is there an option to visualize data on Eurostat directly in map mode? Joe, that's for you again.
Yeah, I mean, not sure what they mean by that, but yeah, I mean, in
the data browser, maybe just let me step in here. I mean, in the data browser, you have directly also the possibility to visualize yourself, geographically, the data from Eurostat.
Okay, very good. Then another question, is there a way to layer images on the map? So say you want to add flags because you're particularly patriotic, let's say. So can you add images on top of the maps? Joe, is that possible?
Yes, so this is possible. It's a bit of a niche functionality, but I didn't show it in the demo because it is quite customized thing. But in the proportional symbol maps that I showed you, you could change the symbol to whatever symbol you want. So if you have an SVG, you can, within the image tool, just paste that SVG, and each region or country in this case would be represented using that SVG. Now that is proportional, so that would be linked to a data set suitable for proportional symbols. But yeah, you could trick it if you want to have them all the same size.
Very good, Joe. And I guess the documentation has something about that available. Yeah,
exactly. Yeah.
You can find it there. So have a look, please. Then let's move on to, I think, a couple of questions where Hannes is probably a bit more to give Joe a bit of a rest. So our 12th question is what advice would you give on how to set up a standard for making maps when we're using a tool such as QGIS?
Okay.
Hannes?
Yeah, thank you for that question. I mean, we have the same discussion here inside. You need to look at this map, that it's designed, that it's clearly designed, that it's not overly cluttered, that you use the correct country boundaries or outlines from an authoritative data source. So we really specify where the data is coming from. Do we have all the rights? And then also have a designer looking at it in several iterations. Is it looking good? You can even see it with our regional yearbook or the map templates which we're using from JISCO, how they have developed over time, where what was fashionable, let's say 20 years ago or 10 years ago, it's not fashionable anymore today. And this is a recommendation I can give from here. Thank you. Back to you, John.
Yeah, thanks, Hannes. There's a question about Lucas land cover and land use estimates here. Are there plans to extend this to NUTS 3? Any plans?
Yeah, I would not want to answer that one directly because I would refer to that to our Lucas colleagues. What I understood is that there were some limitations or some restrictions why the dataset has not been published at the NUTS 3 level. So from a statistical point of view, only NUTS 2 was possible, but I think that should be answered by our Lucas colleagues. Sorry, we cannot go in further detail here.
That's okay, Hannes. We'll add that answer into the Slido after the webinar, so we'll have a written answer there to cover that. Then question 14 is about machine learning methods, and actually the way I interpret this is, will you and Hannes be replaced by AI anytime soon?
Sure.
Please answer.
Yeah. I mean, we know machine learning can help. We are not using it for the moment. We know that some of our colleagues in the NSIs and the National Statistical Institutes, in the geographic departments there, are starting to experiment with that one, for example, with segment anything, with other machine learning, also method, artificial intelligence, how to detect, for example, solar panels. There's a wide variety of these applications already in the NSIs, which we observe. Ourselves from GISCO side, we are not using it currently in production. There's also to be seen, for example, if you ask now in the cloud, create me a map of Germany, and you see the geometries coming back, I'm questioning the results of that one. We all know that artificial intelligence or ChatGPT or whatever you're using for that one sometimes hallucinated, and then suddenly you get Germany in the boundaries from 1930, and this is something like which we clearly should avoid. And I think this is where we need to be really careful how and where we apply artificial intelligence or machine learning for our algorithms.
Thank you, Hannes. Indeed, I think this is a general issue, isn't it, about we want to use it, but we want to be careful and step by step to make sure we use it properly.
Right.
And maybe another question for you, Hannes. Question 15 is, which international coordinate system can best be used at NUTS 2-3 level? So you're talking about a kind of a NUTS area, but you can't pinpoint it using your longitude and latitude that you mentioned earlier. How does it work, Hannes?
I'm just trying to interpret that question. Coordinate system. I mean, sorry, for Europe, we have a couple of defined coordinate system where a group of people, scientists back at the GRC in, when was it actually, in 2003, published a report, the famous Anoni report on map projections for Europe. If my screen could be shared again to the audience, I put it up there. So, for example, there's EPSG code 3035, which is what I mentioned earlier, early on, ETS 89 extended, LEA Europe. And this is what is our recommended projection for all of our data sets. And this is also what we require, for example, for the NUTS data sets, or where we publish our NUTS data sets, also for the population grid, which we are using for disseminating the data. So this is our recommendation for that one.
Yeah, thanks, Hannes. I think we won't go into that in more detail. I think we'll make sure that maybe the link is put into the answer in Slido, and then people can read the relevant report and
Exactly.
see. So, okay, I'll give you a bit of a rest, Hannes, and let's move back to Joe. So the 16th question here is the map from image downloadable only as an image or also as a vector file for further edits? Joe, please.
Yes. It's downloadable as an SVG, so you could export it as an SVG and edit it yourself in an SVG editor.
Okay, so SVG output, you just select that and then you can get to where you want. Very good. Then we've got the 17th question, which is, can we use global filters with update data when we select another region or country? Joe, do you understand that question? Please help.
Not sure what they mean by that, but when you select a data set from the Eurostat database and you select a set of filters, they are maintained no matter what change you make to the map. So the data set will only change if you change the filters yourself. Okay, so you're basically in control of the filters if you choose to be, but otherwise it's global. So that's the idea. Very good. Then another question is about embedding maps in a dashboard. So our 18th question on the list.
how would that work? Would you export the map and then put it into a later dashboard? I mean, is there a dashboard facility? Please, Joe.
Yeah, I think the most common dashboards accept sort of HTML files if you want to embed it. So you could export it as an HTML JavaScript file and then embed it in whatever dashboard you have.
Okay, very good. So that's a little bit back to the user to actually take the map and then use that image. And of course, as we mentioned earlier, you can export the map in these different formats. So whatever might be best embedded could be the format choice. Then another question, I think for you, Joe, using an API to upload the data automatically. How does that work?
So you can't upload data using an API. You could download the data using the Eurostat API, but you can't upload.
Okay, so just maybe as a follow-up for that, though, if you're using your own data, because I understand that actually you don't necessarily have to use Eurostat data all the time, you could still put that into the tool and combine it with Eurostat data. Is that right, Joe?
Yeah, exactly. So you could upload your own data as a CSV or an Excel, and that could be either NUTS codes, or if you're using a world map template, you could use ISO codes.
And maybe just to jump in, so what we have seen, what colleagues have done, they have uploaded an Excel file, then downloaded the configuration file, written and script locally back home, and then uploaded all these modified Excel files in the batch map making, which Joe just mentioned before. So this is certainly not an API where you can upload it, but I mean, that's the other way around to circumvent that we cannot use an API to upload the data automatically, but you can make your maps automatically if you just upload 100 Excel files.
Thank you, Hannes. So we're about 5 minutes away from the end of the Q&A session, and we're breaking all records when it comes to answering questions. But let's try and make the best use of the last 5 minutes. So there's another question here, which is there a template for mapping neighbours, including EFTA countries? So maybe Joe, how do neighbouring countries work?
Yeah. So as I showed earlier, each individual country has its own template. This also includes EFTA countries and candidates. So yes, they are available in the country template section of Image.
Very good. I mean, if you want to go further than EFTA and candidate countries, then that's more tricky. You'll need to find something else to do that for you, of course.
Exactly.
Very good. Okay, give you a rest, Joe, and let's throw the next question at Hannes. So the next question, Hannes, the 21st question: is it possible to download basic data, NUTS polygons, whatever they are? So please tell us, Hannes.
Yeah, not in the image application itself. Yeah, well, for sure you could always download the SVG or without any data. But I mean, as mentioned in my earlier slide in the presentation, and the link is there in the JISCO reference data section, you can just download the NUTS polygons and you will find the different levels of NUTS polygons. You can download different projections and different points. You can have the labels for the NUTS polygons, you can have the regions, or even just simply the lines if you need.
Okay, thank you very much, Hannes. Then maybe back to Joe. Can I also generate my own color scheme? So if I want a really bizarre color, can I put it in myself?
No. So this is on purpose. We don't allow people to add their own color schemes because they are under strict control. So they're tested for color blindness, for to make sure they're cartographically sound. So there are a couple of cartographic rules that need to be followed when using different color schemes. So as I said before, this is aimed at non-experts, so we don't want them to make any mistakes. So we don't allow them to add their own color schemes because of these mistakes that could possibly be made. So no, sorry.
Yeah, on the other hand, that's good news because we're helping people creating maps to actually automatically build in help for visually impaired people and so on. So the colors are actually very important for accessibility, right? Yeah, absolutely.
Exactly.
The next question is close to my heart, which is about GDP data and is it available? And maybe we'll answer that as a written follow-up, but GDP only goes down to a certain level. We'll post that as a written reply, I think, directly, just to get through the questions. Here, I think it's related to the earlier question about explaining how to use two different kinds of color scheme. Can you mix the approved color schemes, Joe?
Yes, I think they're referring to sequential versus diverging. So sequential, if in doubt, use sequential. Low values to high values. Diverging is where you have a critical midpoint. So the example I mentioned was population change. So you want to show population increase in one color scale and population decrease in another. So yeah, any data set that has this kind of critical midpoint, in this case 0, you would want to use a diverging scheme. Otherwise, on a choropleth map, I would recommend you use a sequential scheme.
Very good, thank you, Joe. So perhaps one last question, but this is a question I think which we alluded to earlier. So sorry, this will be the last question, everybody, but we will certainly make sure that the written answers are published into Slido as a follow-up. So please do come back to Slido in a few days. And you will find us having put in as many answers as we can to your questions. So the last question is really advertising for other map making systems, which could potentially be for the whole world. So Joe, Hannes, can you mention, maybe without necessarily restricting it, are there other worldwide map making tools freely available that people could use? Maybe mention a few of them without being exhaustive.
I mean, you can make a world map in image, but if you wanted to use a different tool, maybe more comprehensive, yeah, some of them that Hannes mentioned, QGIS is a standard open source GIS tool, or Esri, which is proprietary. Other than that, there are a couple of tools for data journalists. If you're looking into getting into coding, you could use Observable. They have notebooks, or you could look at Data Wrapper, which is a similar website to Image, and they also have world maps.
Right. Yeah. Thank you, Hannes. Anything to add on that?
No, I just, you will find a couple of, like Image, you will find also a couple of more in the wild, which are doing that one. The intention here for the Image tool was to support our policy officers in the commission at the first case in making these maps, and this is why we built it. And I mean, even with the source code, could be reused wherever and adapted to their specific needs.
Thank you very much, Hannes. And so let's draw a close. I think obviously from the last question, if you're making maps on Europe, use this tool because it's great, we've seen. But indeed, the other questions we will answer in writing in the coming days in Slido. So please go back to that link and you'll start to find your answers. Listen, it's been an incredibly intense session today, incredibly intense webinar. I think we've broken all records on answering at least 25 questions there. So I hope everybody's found this extremely useful. Thank you very much to Hannes and Joe for taking us all through this. And as I said, the tool is there. Please feel free to play around with it. There's plenty of documentation to get into it. Thank you also to the audience for the many questions. It was a great engagement from you. If you would like to give us some feedback on this webinar, there's a survey which we've opened on the Slido page, and there again is the Slido details in case you want to just make a final note. And there'll be a survey there, so you can give us a bit of feedback about what you felt was good, maybe what you felt was bad, hopefully not too much. And indeed, if you have any kind of further issues or questions you want to bring, Eurostat has a multilingual user support, but of course the questions are in Slido and you'll have written answers there as well. So that's it on creating maps. I'd just like to make a little bit of publicity for 2 webinars that are upcoming from Eurostat's side. So on the 14th of May, you'll be able to follow an introduction to Eurostat's top and trending skills tool. So if you're interested in skills, people's skills, then by all means, please come on the 14th of May for the webinar. And then there's a second webinar on the 21st of May, which is the issue of unlocking informed decisions with high quality statistics. So if you're interested in the link between statistics and decision making, then tune in on the 21st of May. So it just leads me to wrap up the webinar now. Once again, thanks to our two speakers. Thanks a lot to the audience for the participation, and we wish everybody online a very good rest of the day. Goodbye, everybody.
Goodbye. Thanks, everyone.
Thanks. Have a nice day. Bye-bye.